Dear student, today we will discuss about the different type of signals which is used and what is the application of communication systems. So we have the classification of signal and system. So what is the signals? And so signal is a pattern of variation that carry information, and signal are represented mathematically as a function of one or more independent variables. A picture is brightness as a function of two spatial variables x and y. In this course, signals involving a single independent variable, generally referred to as a time t, are considered, although it may not represent time in a specific application. So a signal is a real value or scalar value function of a independent variable t. So there are some examples of signals also here. So first one is the electrical signal. So electrical signal, voltage and current in a circuit. So that is the electrical signals. And second one is the acoustic signals, a audio or speech signals, analog or maybe digital. That is the example of acoustic signals. Third one is video signals. So intensity variation in an image or a cat scale. So these are the video signals examples. Next one is the biological signals. So sequence of base in a gene, that is the biological signal examples. And next one is the noise signal. So a unwanted signal is the example of noise signals. So how can we measure a signal? So then we have two parameters in a signals. One is the amplitude and second one is the time. So amplitude and period or time is the two measuring factor of a signals. Next one is what is the definitions of different parameters. So first parameter is the, what is the voltage. So voltage, the force which move an electrical current against resistance. So this is the voltage. And next one is waveform. The shape of the signal, previous slide, is a sine wave and derived from its amplitude and frequency over a fixed time. Other waveform is a square waveform. So this is the waveform. We can also see in this figure. This is the example of waveform. Next, what is the amplitude? The maximum value of a signal measured from its average state. So that is the amplitude. And what is the frequency or pitch? The number of cycles produced in a second, hertz, and relate this to the speed of a processor, or for example 1.4 gigahertz or 1.4 million cycle per seconds. Now what is the signal basics? So here continuous time ct and discrete time dt signals. So these are the two examples of basic signals. So first one is the example of analog signal and second one discrete time is the digital signal. And both these signal we also see in this diagrams. So first is the analog signal xt, and second is show the digital signal xn in the discrete form. CT signal takes on real or complex values as a function of an independent variable that range over the real number and are denoted as xt. That is the CT signals, continuous time signals. Next one is the discrete time signals. So DT signals take on real or complex values as a function of an independent variable that range over the integers and are denoted as. Note the here the CT and DT signals. These are the two examples of basic signals, and the next examples of analog signals, that is the human voice. That is the best example of analog signal. And second one, ear recognize sounds 20 kilohertz or less. And next example of analog signal is AM radio and FM radio. This is the examples of analog signals. And AM radio have the frequency 535 kilohertz to 1605 kilohertz. In FM radio having the frequency range from 88 megahertz to 108 megahertz. So these are the some examples of analog signal which we can see in these figures, different figures given here of the analog signals. Next one is the digital signals. So digital signals represented by a square wave, all data represented by a binary values, single binary digit, that is the bit, and transmission of continuous group of bit is a bit stream. Not all decimal values can be represented by the binary. So binary is the 0 and 1, that is the bits, digital bits, and two digits, 0 and 1. And what is the advantage of analog signals versus digital signals? So analog signal have the advantage. This is the best suited for audio and video purpose. Second one advantage is the consume less bandwidth. Third one is the available worldwide. And next one is the less susceptible to noise. So these are the some advantage of analog signals. And next one is the digital signal advantage here. So first one is the best for computer data. And the next advantage of digital signals is can be easily compressed and also can be encrypted. And next one is the equipment is more common and less expensive and can provide better clarity. So these are the some advantage of digital signals. Analog message. So what is the analog message? Analog message continuous in amplitude and over time. So AM, FM for voice sound. Next one is traditional TV for analog video. First generation cellular phone, analog board, and recorder players. Digital message are 0 or 1 or discrete values. So example of digital message. So Here BCD, DVD, 2G, 3G, cellular phone, data on your disk, your grade, and digital age, why digital communication will prevail. So analog to digital conversion and digital to analog conversion, gateway from the communication device to the channels, and what is the Nyquist sampling theorems in communication system. So from time domain, if the highest frequency in the signal is B Hertz, the signal can be reconstructed from its samples taken at a rate not less than 2V samples per second. So this is the Nyquist sampling theorem in communication field. So signals are variable that carry information. It is described as a function of one or more independent variables. Basically, it is a physical quantity. It varies with some independent or dependent variables. So signal can be one directional or multi-dimensional is possible. So signal a function of one or more variable that convey information on the nature of a physical phenomena. So this is the signal. An example of VT, IT, XT, heartbeat, blood pressure, and temperature, vibration. These are the examples of signals. One-dimensional signal function depend on single variable. For example, speech signals. And multi-dimensional signals function depend on two or more variables. For example, images. So image is the example of multi-dimensional signal, and speech signal is the example of one-dimensional signals. Classification of signals. Next is the classification. So first one is the continuous time and discrete time signal. Second one is the periodic and non-periodic signals. Third one is the casual and non-casual signals. Fourth one is deterministic and random signals. And fourth and last and fifth is the even and odd signal. So these are the some classification of the signals. So continuous time and discrete time signals. CT signals is taken on real or complex values as a function of an independence variable that range over the real numbers and are denoted by xt. And DT signal take on real or complex values as a function of an independent variable that range over the integer and are denoted by x. And note that suitable note that sub use of parentheses and square brackets to distinguish between CT and DT signals is periodic and non-periodic signals. Periodic signals have a property that x t plus capital T equal to xt for all t small t. The Smallest value of capital T that satisfy the definition is called the period. Shown below are non-periodic signals left and periodic signals right. So here two signals. First one is the non-periodic and second one is the periodic signals. In these two figures, casual and non-casual signals. A casual signal is 0 for t is less than 0 and non-casual signal is 0 for t greater than 0. So what is the casual and non-casual signals? A casual signal is 0 for t is less than 0 and non-casual signal is 0 for t is greater than 0. So there are two examples of casual and non-casual signals. As we can see these two signals in these two figures given here. And what is the right and left sided signals? So a right sided signal is 0 for t is less than capital T and a left sided signal is 0 for t is greater than t, where t can be positive or negative. So these are the right and left side signals. Next one is the deterministic and random signals. So behavior of these signals is predictable with respect to time. There is no uncertainty with respect to its value at any time. So these signals can be expressed mathematically. For example, xt equal to sine 3t is a random or deterministic signals. And random signals, behavior of the signal is random. Or example, for example, not predictable with respect to time of random signals. There is an uncertainty with respect to its value at any time. So these signals can't be expressed mathematically. For example, thermal noise generated in non-deterministic signals in this figure. So this is the example of thermal noise generated is non-deterministic signals. Next one is the even and odd signals. Even signals x, et and odd signal x, ot are defined as x, et equal to x, e minus t and x, ot equal to minus x, o minus t. Any signal is a sum of unique odd and even signals using xt equal to x, e t plus x naught t and x minus t equal to x e t minus x naught t and x e t equal to 0.5 xt plus x minus t and x naught t equal to 0.5 xt minus x minus t. So and also even and odd signals. So example of even signals is if x minus t equal to xt, this is the even signals, and x minus n equal to xn, this is the example of even signals. Next one is the odd signals. In odd signal, x minus t equal to minus xt and x minus n equal to minus xn. So this is the examples of odd signals. Any signal xt can be expressed as xt equal to xet plus x naught t, and x minus t equal to xet minus x naught t, where xet equal to 1 by 2 into xt plus x minus t, and x naught t equal to 1 by 2 into xt minus x minus t. So next one is the bounded and unbounded signals. Every signal is bounded, but meaningful signal is always bounded. So in this figure, the casual and anti-casual signals. So in casual signals, show the bounded and unbounded waveforms, and also in anti-casual there is bounded and unbounded waveforms. Power and energy signals. In power signals, infinite duration. Normalized power is finite and non-zero. Normalized energy average over infinite time is infinite. And in power signal, mathematically detectable. What in energy signals? Energy signal finite duration, and normalized energy is finite and non-zero. And energy signals normalized power average over infinite time is zero. And energy signal is the physically realizable. Next one is the elementary signals. So there are some types of elementary signals. First one is the step function. Second one is the impulse function, and third one is the ramp function. So these are the some elementary signals. First one is unit step function. So we represent unit step function by the ut. So ut equal to 1 when or if t is greater than 0. Ut equal to 0 when t is less than 0. This is the unit step function is continuous time signals. What in discrete time signal? Unit step function un equal to 1 when n is greater than equal to 0, otherwise equal to 0 when n is less than 0. So these are the unit function in ct and dt signals. Next one is unit impulse function. So we represent the unit impulse function by the delta t. So delta t equal to 0 when t is not equal to 0, and delta t equal to integration of minus infinity to infinity delta t dt, or equal to 0 to plus 0 delta t dt equal to 1. That is the in ct signals. And in dt signals, the unit impulse function is delta n equal to 1 when n equal to 0, and delta n equal to 0 when n is not equal to 0. Unit ramp functions. Rt equal to t or 0. Rt equal to t when t is greater than equal to 0, and Rt equal to 0 if t is less than 0. And Rt equal to t ut. So ut equal to 1 upon dt Rt, and d upon dt into r equal to 1. So Rn equal to n if n is greater than 0, and Rn equal to 0 when n is less than 0. What is a system? So system processes input signals to produce output signals. For examples, a circuit involving a capacitor can be viewed as a system that transforms the source voltage or signal to a voltage or signal across the capacitor. Next example, a CD player takes the signals on the CD and transforms it into a signal sent to the loudspeakers. And next example is a communication system is greatly composed of three subsystems: the transmitter, the channel, and the receiver. So these are the three subsystems of a communication system. The channel typically attenuate and add noise to the transmitted signal, which must be processed by the receiver. Next, how is a system represented? So a system takes a signal as an input and transform it into another signals. So input signal is the xt and output signal is the yt. So system transfer the input signal into the another output signals. So in a very broad sense, a system can be represented as the ratio of the output signal over the input signal. So this is the system. That way, when we multiply the system by the input signal, we get the output signals. This concept will be firm up in the that way when we multiply the system by the input signal, so we get the output signal. And next one is the types of signals. So there are different types of signal. First one is the casual and non-casual systems. Second one is the linear and non-linear systems. Third one is the time variant and time invariant system. Fourth one is the stable and unstable systems. And last one is the static and dynamic system. So there are some types of systems. So first, what is the casual system? In casual systems, a system is said to be casual if the present value of the output signal depend only on the present and or past value of the input signals. So example, yn equal to xn plus 1 upon 2 into x and minus 1. Next one is the non-casual system. In non-casual system, a system is said to be anti-casual if the present value of the output signal depend only on the future value of the input signal. So here example, yn equal to xn plus 1 plus 1 by 2 into x n minus 1. Linear and non-linear system. A system is said to be linear if it is satisfy the principle of superposition. For checking the linearity of the given system, first we check the response due to linear combination of inputs. Then we combine the two outputs linear in the same manner as the input are combined, and again total response is checked. If response in step 2 and 3 are the same, the system is linear, otherwise it is non-linear. So This is the linear and non-linear system concept. Next one is the time invariant and time variant system. If a system is said to be time invariant, if a time delay or time advance of the input signal leads to a identical time shift in the output signals. So yit equal to h into xt minus t naught and h into x t0 xt equal to h x t0 into xt or y naught t equal to x s t0 y t and x y naught t equal to s t0 h x t equal to s t0 h x t. Next one is the linear time LTI system. In LTI system, special importance for their mathematical tractability. Most signal processing application involve LTI system. LTI system can be completely characterized by their impulse response. So yt equal to t into x and equal to t summation of k equal to minus infinity to infinity x k delta n minus k and k minus infinity to infinity summation of x into kt delta n minus k equal to summation of k minus infinity to infinity xk hk n. So summation of minus infinity to infinity of k xk h n minus k equal to xk into hk. So this is the LTI system. Next one is the stable and unstable systems. A system is said to be bounded input, bounded output, stable if every bounded input results in a bounded output. So example of stable and unstable system. The system is represented by the yt equal to axt is unstable when a greater than 1. Reason, let us assume xt equal to ut, then at every instant ut will keep on multiplying with a and hence it will not be bounded. Static systems. A static system is memoryless system. It has no storage devices. Its output signal depend on present values of the input signals. And for example, IT current equal to 1 upon R Vt. This is the example of Ohm's law here. Next one is the dynamic systems. A dynamic system possesses memory and it has the storage device. In dynamic system is said to possess memory if it is output signal depend on past values and future values of the input signals. So here it equal to 1 upon L integration of minus infinity to t vt dt and yn equal to xn plus xn minus 1. Next one is the memoryless systems. A system is memoryless if the output yn at every value of n depend only on the input xn at the same value of n. For example, square yn equal to x n ka whole square and sine equal to yn equal to sine xn. And counter example, for ideal delay system yn equal to x n minus n naught. Discrete time systems. Next one is the discrete time system, DT system. Discrete time sequence is a mathematical operation that maps a given input sequence xn into an output sequence yn. So example discrete time systems, moving running average yn equal to txn and yn equal to xn plus xn minus 1 plus xn minus 2 plus xn minus 3. For maximum yn equal to maximum xn minus 1 into xn minus 2. Ideal delay system yn equal to xn minus n. So there are some properties of the system. So xt is the input and yt is the output of this system, and h is the transfer function in figure A, and figure V yn is the output signal and xn is the input signal, and s the transfer function of this signal. So notation h represents the system xt equal to or tends to yt represent a system with input xt and output yt. So stability, bounded input, bounded output, stability. So here xt is less than mx less than infinity and equal to yt less than my less than infinity, and also xn less than mx less than infinity equal to yn less than my and my less than infinity. Memory systems. So present output value depend on future or past input in memory system. Memoryless system, present output value depend only on the present input. So this is the example of memoryless system. So memory system examples is yt equal to 5xt plus integration of minus infinity to t xt dt, and yn equal to m equal to n minus 5 summation n plus 5 xn. So memoryless system yn equal to xn plus x square n. Casual, present output depend on present past value of input, and non-casual system, present output depend on future value of input. Note memoryless equal to casual, but casual not necessary to be memoryless. Next one is the time invariance, TI, time delay or advance of input and identical time shift in the output. So let us define a system mapping yt equal to hxt. The system is time invariant if xt minus t0 and tends to yt minus t0, and x n minus n0 tends to yn minus n0. And next one is the linearity system if x1t equal to y1t and x2t tends to y2t, then ax1t plus bx2t tends to ay1t plus by2t, else nonlinear. So superposition property, addition, unity, scaling. So properties of the system. On this course, we shall be particular interested in signal with certain property. First one is the casual. A system if is casual if the output at the time only depend on input value up to that time. Linear, a system is linear if the output of the scaled sum of two input signals is the equivalent scaled sum of outputs. Time invariance. A system is time invariant if the system output is the same given the same input signal regardless of the time. These properties define a large class of rectangle useful system and will be further considered in the coming next topics. Coming next topics. So these are two reference books for this topic. First one is Digital Communication by Simon Hagen. Second one is the Principle of Communication by Todd Silliman. There are some multi-choice questions, so we will discuss these multiple questions one by one. Which mathematical notation specify the condition of periodicity for a continuous time signal? Option A, xt equal to x into t plus t naught. Option B, x n equal to x n plus n. Option C, xt equal to e to the power minus alpha t. Option D, none of the above. So correct answer here is option A, xt equal to x t plus t naught for the periodicity for a continuous time signals. Next question, which property of delta function indicates the equality between the area under the product of function with shifted impulse and the value of function located at unit impulse instant. So option first A, replication. Second is the sampling. Third one is the scaling. And option D is the product. So here correct option is the B, sampling. In next question, damped sinusoids are. Damped sinusoids are. Option A, sinusoidal signals multiplied by a growing exponentials. Option B, sinusoidal signals divided by a growing exponentials. Option C, sinusoidal signals multiplied by a decay exponentials. Option D, sinusoidal signals divided by the decay exponentials. So here correct answer is option C, sinusoidal signals multiplied by decaying exponentials. So correct answer here option C. Next question, a system is said to be shift invariant only if option A, a shift in the input signal also result in the corresponding shift in the output. Option B, a shift in the input signal does not exhibit the corresponding shift in the output. Option C, a shifting level does not vary in an input as well as output. Option D, a shifting at input does not affect the output. So here the correct option is the option A, a system is said to be shift invariant if a shift in the input signal also results in the corresponding shift in the output. So here correct answer is option A. Which condition determines the causality of the LTI system in terms of its impulse response. So option A, only if the value of an impulse response is 0 for all negative values of time. Option B, only if the value of an impulse response is unity for all negative values of the time. Option C, only if the value of an impulse response is infinity for all negative values of time. Option D, only if the value of an impulse response is negative for all negative values of the time. So here correct option is A, only if the value of an impulse response is 0 for all negative values of time. Next questions. Under which condition does an initially relaxed system become unstable? Option A, only if bounded input generated unbounded output. Option B, only if bounded input generated bounded outputs. Option C, only if unbounded input generates unbounded outputs. Option D, only if unbounded input generates bounded output. So here, correct answer is option A. Under which condition does an initially relaxed system become unstable? System become unstable when only if bounded input generates unbounded output. So this is the condition for uh, any system when become unstable. So option here, correct answer option A. In next questions, an equalizer used to compensate the distortion in the communication system by faithful recovery of an original signal is nothing but an illustration of. So option first A is static system, option B dynamic system, option C invertible system, and option D none of the above. So an equalizer used to compensate the distortion in the communication system by faithful recovery of an original signal is nothing but an illustration of the invertible system. So correct answer here option C. In next question, which block of the discrete time system require memory in order to store the previous inputs? So option A adder, option B signal multiplier, option C unit delay, option D unit advance. So here correct answer is option C unit delay, because which block of the discrete time system require memory in order to store the previous input? So that is the unit delay. So correct answer here option C. In next questions, which among the following belongs to the category of non-recursive system? So option A A casual FIR system. Option B, non-casual FIR system. Option C, casual IIR systems. And option D, non-casual IIR system. So here, correct answer is the option A, because which among the following belong to the category of non-recursive system? So category of non-recursive system is the casual FIR system. So here correct option is A. Thank you. Thank you very much.